Okay, so let's take a look at our problem statement for our next program. And in this particular problem statement, we're going to see some fictitious botany, so don't take any of this as being literal. And one of the things that we want to do as we read through this problem statement is try to analyze it and find out maybe what our inputs are going to be, what sort of conditions we may have, and then what sort of output we're interested in producing. So we have here a red seed, and we're told that this red seed will grow into a flower. So let me go ahead and mark that we're talking about a red seed here with my little highlighter. So it will grow into a flower when planted in soil temperatures above 75 degrees. So we've got to be above 75 to get a flower. Otherwise, it will grow into a mushroom. So we'll say otherwise we get a mushroom here. Assuming that the temperature meets the conditions for growing a flower, planting the red seed in wet soil. So if we plant it in wet soil, it will produce a sunflower. And planting the red seed in dry soil, so I'll mark this dry soil, it's going to produce a dandelion. So that's really the main pieces of information there from the first paragraph, and being able to pick that out is fairly important. All right, so the next thing we're looking at is a blue seed. So we've got this choice between a red seed and a blue seed. And it will grow into a flower when planted in soil temperatures that range between 60 and 70. And then otherwise, it's also going to grow into a mushroom. So if it's not planted between 60 and 70, it's going to grow into the mushroom, just like our red seed did for temperatures that were below 75 degrees. So assuming that the temperature meets the conditions for growing a flower, planting the blue seed in wet soil, so in wet soil it will produce a dandelion, and planting the blue seed in dry soil will produce a sunflower. So basically the opposite of what we had before. So what do we have to do? We got to write a program that will ask the user to input the seed color, and then they have to input the soil temperature. And then finally, they will input whether the soil is wet or dry, so basically the soil moisture. And then they need to output what will it grow. So is it going to grow a mushroom? Is it going to grow a dandelion? Or is it going to grow a sunflower? That's basically the three choices we have. So we read over our problem statement. We've analyzed it to a certain degree. We realize what our inputs are. We know the basic conditions that we have, and we also know under what conditions what will actually grow. So let's go ahead and go over to Eclipse and start writing up some pseudocode for this. All right, so it looks like we're ready to start doing some pseudocode here for Program 4. So I've already created the Program 4 project folder and also created the Program 4 source file within that project folder. So here we are with the problem statement, so I just copied this in so we can reference it as we write our pseudocode. If you need to go back to Program 1, 2, or 3, in any of those, I'll show you how to create a project folder and also how to include a source file in Eclipse. Okay, so let's take a look at writing the pseudocode. So the first thing that we need to think about for our pseudocode is what input we need to get from the user. So there's really three pieces of information that we need to get from the user. One's the seed color, two is the temperature of the soil, and three is the moisture of the soil. So is it wet or is it dry? So I'm going to just indicate this by doing get seed color, and then we need to get temperature, and then finally we need to get the soil moisture. So I'll write that as soil. So once we have those three pieces of data, then we can actually make some decisions. So based off the seed color, we would do one set of actions. Based off of the temperature, we'll do something else. And then based off of whether the soil is moist or wet or dry, then we'll do some other set of actions. So the first thing we need to look at is if we have a red seed. So if red seed, we'll do some set of actions. If blue seed, we'll do some other set of actions. So I'm going to come in here and tab over below this if red seed. So this is saying that if it turns out that we have a red seed, let's do these set of actions. So that's why I've tabbed over here. So I'm associating this set of pseudocode with that action. All right, so now we can look at what? Well, if we come back up here, we see that if the soil temperature is above 75 degrees, then we'll get some sort of flower. And if it's not, then we'll get a mushroom. So we can say if temperature is greater than or equal to 75, we'll do one set of things, and otherwise we'll get a mushroom. So I'll just say output mushroom. Okay. So if the temperature is in fact greater than or equal to 75, we have two alternatives there. One results in a sunflower and the other results in a dandelion. So if the soil is wet, we'll want to output dandelion. Let's see, dandelion. If the soil is dry, then will result in a actually I have that exactly backwards. Let me make sure I get this right. So that was a mistake. So that should be sunflower there, and this should be dandelion down here. Okay. So if the soil is wet, output sunflower, and the soil is dry, output dandelion. All right, so you guys need to keep me straight here and make sure I'm not saying the wrong stuff. It says one thing here, and I'm trying to type out something else here for our pseudocode. Now, it totally destroyed our solution before we even got started. So that's not good. All right, so that's pretty much what's going on with our red seed. So if the red seed, we can check on the temperature and then check on the moisture, whether it's wet or dry. If it doesn't meet the temperature, if it's not above 75 or at least 75 and above, then we'll get a mushroom. All right, so let's look at blue seed and what happens. So with blue seed, if we scroll back up here and look at the problem statement briefly, we see that we get some sort of flower if the temperatures range between 60 and 70. Okay, so we'll test that. So I'll come down here and say if temp is between 60 and 70, we'll do one set of actions. Otherwise, if it's not, what do we get? We get a mushroom just like before. So we want to output mushroom. Okay, so let's focus in on what happens if the temperature is in fact between 60 and 70. So going back up here, it says that if the temperature is between 60 and 70, so it meets the temperature conditions, then planting the blue seed in wet soil will produce a dandelion, and planting the blue seed in dry soil will get a sunflower. So it's exactly opposite of what we had with the red seed, even though I tried to type that backwards whenever we're dealing with the red seed. But now we can type out if the soil is wet, then we'll get a dandelion. Let's see. Dandelion, it's a hard word to spell sometimes. Maybe it's just my typing. And if the soil is dry, then we will output a sunflower. And that's basically it. So this is the general pseudocode that we have here. We have the check to see what kind of seed we have, and then based off the seed we look at the temperature, and then if the temperature is in the right conditions for a flower, we look at whether the soil is wet or dry, and we output that information appropriately. So that is our pseudocode. So now we'll come back and start filling in some actual source code. Alright, so let's go ahead and start putting in our source code, and we'll start with our pound include. So we have pound include IOStream. Then we need to have pound include string. Okay, since we're going to have some variables that are going to be of type string, and then using namespace space standard semicolon. Okay, so now we're ready to start typing in the main function. So let's come down a couple lines and type in int main open paren close paren, and then come down a line and type in an open brace. And then if you want to, you can select the rest of this pseudocode here, and we'll just tab it over. So once you select it, you can hit the tab key and it'll tab all of that pseudocode over. since we want to have all of this inside of the main function. And also at the very bottom here, you can put in a close brace. All right, so now we're ready to start typing in our main function here. So let's come down and do get the seed color. So in order to get the seed color, we need to have a variable that's capable of holding whatever color that's typed in by the user. So we'll declare a string variable, and we'll call it seed color. And we'll set it to the empty string. So we've got our declaration statement here. Now, one thing that I want to point out that I haven't pointed out before is that whenever we declare variables and they're a multi-word variable name, the convention is, or the convention that we're using, is to have the first word lowercase and any subsequent words, they will be what we call camel case, meaning that the first letter is capitalized and then the rest of the letters are lowercase. And this actually aids in being able to see that we do in fact have a multi-word variable. So you can actually see the delineation because we have that uppercase C there. Again, this is just a convention. It's not required by the compiler. So you could name it, X, but that's not really indicative of what this variable does or means. So we want to have a variable that holds the seed color, so why not name it seed color? Okay. So then once we have that, we can then have a prompt to the user using our cout. So we'll do cout and say enter the seed color. And we'll put in parentheses here, red or blue. And we'll assume that we have good users for right now and they type in red or blue. They don't type in purple or green or hamburger or something like that. So once we have the prompt there, then we can read in whatever they type on the keyboard. So we can use our cin, and then what we will want to do is store whatever they type in into the variable seed color. And that's basically it. So this is nothing new. We're just using some of the things that we had learned from our previous programs. So get temperature, in the case of the temperature, we will want to have that as some sort of numeric value because we'll want to compare it to other numeric values. So we'll store this into an integer value since I guess you could store it into a double. Our temperature may have a fractional part. For right now, we're going to say that our temperature is not going to have a fractional part. So we'll just put it in an integer variable. So we'll do int temp and set it to 0. So initialize it to 0. And then we'll do cout. We'll say enter the temperature. And maybe we'll put F here to indicate Fahrenheit. Even though we're really not keeping track of units. Units are important, but for this program we're going to ignore the units related to temperature. We'll just add that in there for fun, I guess. So then we'll do cin and then use the extraction operator and type in the variable name where we want to store the temperature that they type in. And then the next thing we need to do is get the soil moisture. So this is also going to be a string variable, and we'll just call it soil moisture. Okay, and we'll assign it to the empty string or initialize it to the empty string. And cout, and then we'll say enter the soil moisture. And then we'll put wet or dry in parentheses here. So sort of prompting the user what we expect them to enter in. All right. Now if the user goes in and enters in something besides what we're expecting, our program is not going to be able to handle that. At least not the way we write it now. We may come back and change it, or in later videos we'll modify this so it actually does a validation of the input. So let's see, we need to have the variable soil moisture here. Okay. So now, once we have our input for seed color, temperature, and soil moisture, we can start making some decisions. So we're getting into some new syntax here. So far in our programs, program 1, 2, 3, and 4, all of our instructions have been one right after the other in sequence. So now we're looking at having some sort of choice or alternative. We're making decisions, and we'll branch off to one set of code based off of what decision is made here. So if it's red, we'll look at these set of choices, and if it's blue, we'll look at these set of choices down here. So the syntax for testing to see if something is true is just a simple if. So almost like our pseudocode, we can say if and use our variable called seed color and check using our relational operator equals. And remember that to test for equivalence, we have to use equal equals, not just a single equal. Single equal means assignment, double equal means equivalence. So here we want to see if the seed color is red. So make sure you put red inside of the double quotes, otherwise it will not be seen as a string. So we're trying to compare one string, which is our one variable here called seed color, which is of type string, to a string literal, and this string literal says red. Alright, so I'm going to put open brace, and then I'm going to put close brace right above the pseudocode for if blue seed. So what we're trying to define here is the body of this if statement. So the body is defined by the open brace and the closed brace. So we're saying that if the seed color turns out to be red, then we want to look at testing these set of actions here. Okay. And the other thing that we want to do is come down below and test to see if, we'll say if seed color is equal to blue, we'll do these set of actions down here. Okay. So we'll come down and make sure we have our closed brace. And the nice thing about Eclipse, it actually lines up our braces. So if you have an open brace and a closed brace, it should automatically align those braces for you. The other thing I should point out about these if statements here, they have to test a Boolean expression here. So whatever we have inside of parentheses, if parentheses something, close parentheses, that thing inside of parentheses has to be a Boolean expression, meaning it has to resolve down to a true-false value. If it doesn't resolve down to a true-false value, then we'll end up with a syntax error. All right, so I'm going to just focus on the red for right now. So if the temperature is greater than or equal to 75, so check out how this source code here, the C++ code, is very similar to the actual pseudocode. So if temp is greater than or equal to 75, then we want to do these set of actions. And I'll put the little close brace in here. Otherwise, we do these set of actions. And the way we go about doing otherwise is we're going to use the keyword else. So we say else, open brace, and then I'm going to come down here and type in the close brace and make sure that it's inclusive of our pseudocode for outputting mushroom. So we could have used else here for our pseudocode, but I just used the term otherwise. So all that's saying is if we have an if statement and that if statement fails to be true, and the only other alternative we have, so in this case, the only other alternative is if that's not true, if the temperature is not greater than or equal to 75, and we've determined that we have a red seed, then we know we end up with a mushroom. So we don't need to have another condition here. So you don't have to go in here and write if temperature is less than 75, because that's the only other, whoops, I forgot my open paren. So we don't have to go in there and write this expression. Now we could do that. There's nothing wrong syntactically with doing that expression there. It's basically doing the same thing that we had before. But there's no reason to test to see if the temperature is less than 75, because if we fail here, if this turns out to be false, then we know the temperature is less than 75. So we can just say else. Okay. All right, so what about if the soil is wet? So we can do a similar test as we did before with the seed color, and this time we'll do soil moisture. So soil moisture, and test to see if the soil moisture is equal to wet. If that turns out to be true, then we'll do our output statement. And if the soil moisture, if I can say it right, turns out to be dry, we will do this output statement. Okay. And you could actually do the same thing here, as opposed to doing two if statements. You could actually do a if, and then you could do a else, assuming that the user, you knew that the user was inputting wet or dry. So if they didn't input wet, then you know that they inputted dry. So we could in fact make this an else statement if you wanted to. I'm going to leave it in here as an if statement for now. Maybe we'll come back and change it. So in order to do the output, we would do cout, and then just output a sunflower would grow. I'll say a sunflower will grow. All right. And down here we'll do cout and do a dandelion. Let's see. All right. So we have that. We may want a new line character in there, so let me go back in here and put a new line character. All right, so we have that. All right, so now that we have all of our code in here for the red seed, let's go and do the same thing or something similar for our blue seed. So we'll come down here, and so we already have this first test here to see if seed color is blue. And now we need to just come in and write some if statements. So if, and this is going to be something new as well, if the temperature is between 60 and 70. So you may be, inclined to write this as 60, and then put less than equal to temp, and then put this here. So maybe something like this. This would maybe be the way that you would write it in some mathematical notation. So basically that's saying the temperature is between 60 and 70. Unfortunately, you cannot get away with this in C++. So let me show you the correct way that we write in this expression. So if we have two bounds that are variable, our value has to be between, we have to express the variable being associated separately with both of those bounds. So we could say temp, well, you could say 60 or temp first. You could say temp is greater than or equal to 60, and temp is less than or equal to 70. So that's the way we have to write that expression there. So if we have a particular value and it needs to fall on a range, we have to specify that particular variable associated with both the lower range and the upper range. And notice that I use the AND Boolean operator here as opposed to the OR operator. So if we had put OR, just to show you the difference here, if we had put OR in here, somebody may put in the temperature of 150. That's a very hot soil temperature, right? So it would qualify here. So 150 is in fact greater than 60. So this would be true. So it doesn't matter if this part was false or not. So really 150 doesn't fall in the range. So we don't need to have the OR operation there. We need to have the AND operation, because both this and the right-hand side, so both the left and the right-hand side need to be true. All right. So come down and put a brace in, and then we'll come down a little bit below here, right above our other closed brace. So what we're saying is that all of this, oops, I actually put my closed brace in the wrong spot. I need to be above the otherwise here. So if the temperature is on our range between 60 and 70, we'll do some code here. Otherwise, which we say else, right? We'll do this. Okay. If you want to, you can go ahead and do the output statement down here. So let me scroll down a bit. So we'll do cout and say a mushroom will grow. Okay, new line character. All right, so now we can check to see if the soil is wet. So we can see if soil moisture is wet. So do that test. And that turns out to be true. We will output using cout and say a dandelion will grow. All right. And the same sort of logic here. Again, we could use the else here as opposed to using if, assuming that we knew that the user had inputted wet or dry. Again, we're not doing any sort of input validation in this program, but maybe for program 5 we'll come back and revise program 4 and show how to do some input validation. And I'll probably show some alternatives, just how to write program 4 and actually improve our logic and see what the difference is whenever we change this up a bit. So soil moisture, and test to see if it's equal to dry. And so we'll come down here and put in our close brace, and then do our cout, and say a sunflower will grow. Okay, so that's the basics of our program. We check to see if we have a red seed or a blue seed, and follow the appropriate logic within those. So you could even have an else operation here. So if the seed wasn't red, we may be able to assume that it was blue. So you could actually put here an else. And we'll come back and change that just to see what the difference is whenever we have the else there versus having the if statement there. All right. Another thing that I will point out real quick is that if we only have a single statement that we want to execute associated with an if, so if this is true, we want to do this output here. So if that's the only statement that we want to have, we do not have to have this open brace, close brace defining the body of this if statement being true. And the same thing goes here, the same thing over here. Well, that's not true. I guess we do need to have, well, no, we don't have to have these braces either because we only have that single statement. But if you have multiple statements associated with an if or an else, then you definitely need to have those braces. For me, and the way that I do my programming, I always put those braces in regardless if I have a single statement or more than one statement. So if I come back and actually add in additional lines, I already have those braces there. And I also find it's just easier to read for me, but maybe that's just what I'm accustomed to. So you can make that decision. If you only have a single statement, then you can just ignore putting in those open brace, close braces. Oh, we actually forgot to do our output statement here for this else. So this should be cout, and then we have a mushroom will grow. All right. So I think that's it. So I think we're ready to save this program and then run it and see how this program works. All right, so I'm going to click on Save, and then I'm going to click on the Build button, build this program. So that's compiling and linking it, and now we'll run it. So down here on the console it says enter the seed color, so I'm going to enter in red. Enter the temperature, I'll say the temperature is 85, and the soil moisture is dry. So it outputs a dandelion will grow, and is that what we expected? So if we go back up here to the paragraph dealing with the red seed, if it's above 75 degrees and the soil is dry, then it's going to produce a dandelion. And that's what we expected, and if you look at our logic, that's exactly what happened. So we had a red seed, temperature was greater than or equal to 75, and the soil moisture was dry, so it outputs a dandelion. So very basic stuff here, and hopefully that makes sense. Let's run it one more time and just test out another path of execution here. So we'll run this. This time we'll type in blue, and we'll say the temperature is 45. And enter in the soil moisture, wet. So it says a mushroom will grow. So let's check that out and make sure that that is true. So if we have a blue seed, and for a flower to grow, it has to be between 60 and 70. In our case, we had 45. And then it says that, so if it doesn't meet this temperature range here, then it will grow a mushroom. And that's exactly what we got. And we can look at our logic to confirm that. Blue, so the temperature was not between this range. So we ended up with the else. So we tested this here. This turned out to be false. So it ends up doing whatever we have here in the else operation. So mushroom will grow. Now, something that you probably noticed here is that we're actually asking for the soil moisture after we've gotten the temperature, and there's really no reason to ask for the soil moisture if we know that we're going to end up with a mushroom. So that's maybe something we can go and change in our program. Okay, so let's look at moving this code here where we get the soil moisture down to the point where it actually matters. So we're going to move these 3 lines of code down below, in the case of the red seed, after we know that we have a temperature greater than or equal to 75, because only at that point in time do we take into account the soil moisture being wet or dry. So if we fall into a situation where our temperature is less than 75, we know that we're going to get a mushroom. It doesn't matter what the soil moisture is. And it's the same case with the blue seed. The blue seed does not fall in this range here in terms of the temperature. Then we're going to end up with a mushroom. So there's no need to ask for the soil moisture until we know that we're in a correct temperature range. So I'm going to just take this code here and select it. I'm just dragging over, left clicking and dragging. And then I'm going to use hold down Control and then hit the X key, and that will cut that bit of code out. And you see that the code analyzer here in Eclipse is already complaining. It's already saying that we have some unresolved variables here. But as soon as we come in here inside of this if statement where we have the if temp is greater than or equal to 75 and paste it, and I'm going to hold down Control and then hit the V key to paste, then the Eclipse code analyzer is not complaining anymore. That's now resolved. Still unresolved down here, so let's go ahead and paste in this bit of code down here as well. So Control V once again, and we paste that code in. So now we're not asking for the soil moisture until it actually matters. So let's go ahead and save this, build it, and we'll run it. So we'll put in red for the seed color, and we'll put in a temperature of 65. So that's down below where we get a flower. And it says that a mushroom will grow. And notice how we did not ask the user for the soil moisture. And that's good. We don't want to ask them unnecessary questions if we already know ahead of time that we're not going to get that result. So let's run it one more time, and maybe we'll do it for blue seed. So we'll type in blue, and we'll put in a temperature of 95. And it says a mushroom will grow. So we exercised the second case here if the seed color is blue. All right, so let's take a look at our code and notice how we have this if statement here to test to see if we have a red seed, and then we also have another if statement here to see if we have a blue seed. And you may be wondering what would happen if we change this to an else statement. So that's saying that if the seed color is not red, then it has to be blue. And that may not be the case, right? So somebody could actually input the color green or brown, or maybe not even a color at all. They could input anything. So anything other than red would actually come down and try to execute whatever we have here in this else statement here. So if the temperature happened to fall between 60 and 70, then we would ask for the soil moisture, and if it happened to be wet, we'd output that a dandelion would grow. But they may have inputted, that the seed color was, hamburger or something like that, something that doesn't even make any sense. So we have to be careful whenever we use this else here. We have to know that we have valid input and that we've exhausted all other alternatives. And the only thing else left is this stuff here. That's where we'd how we would use the else statement. So we could, I guess, leave the else in there if we came up here and maybe did something like this. So after we get the seed color, test to see if the seed color is not equal to red and the seed color is, seed color is not equal to blue. If that turns out to be the case, maybe we'll just output to the user. We'll do a cout and then say invalid color selected. Program will terminate. Okay, so we could have some bit of code like this, and then we could do maybe a return 0, and that would actually terminate our program at that point in time. So if we had that, it would actually be okay to have an else statement in here, because if they input anything other than red or blue, it's going to come in here and execute this statement and then do the return 0, meaning it's going to exit out of our main program, or our main function. Notice how we did construct this particular Boolean expression here. We said seed color not equal to red and seed color not equal to blue. You have to be very careful. If we would have used the OR here as opposed to the AND operation, let's notice what happens, because this is a common mistake as well, that someone would put an OR here instead of an AND statement. So with the OR, maybe they type in blue, okay? So blue is not equal to red, right? So this would be a true statement. And we only have to have one true statement in order for this whole thing, in order for this whole entire expression to be true. So we would end up executing this statement here, and that's not what we wanted to have. We needed to have both of these being true. So if they typed in blue, this would turn out to be true, and this would be blue is not equal to blue. That is in fact false. So true and false with the AND operation, the whole expression turns out to be false, and so we wouldn't execute this bit of code here. And that's what we would want to have happen if they typed in blue. So do be careful between using the AND and the OR operations, and test out your logic. All right, so let's see how this works. I'm going to save it, build it, and then run it once again. All right, so we'll type in brown. And it says invalid color selected, program will terminate. And that's exactly what we expected to happen. Let's go back and run it one more time and make sure it does work if we type in blue. So let's type in blue. And we'll put in a temperature of 75. And it has a mushroom will grow. And that's exactly what we expected, because it did not fall into this temperature range. Let me scroll down a little bit further to get to the blue section. So yeah, it didn't fall in between the 60 and 70 range. So we ended up with a mushroom here. So it's perfectly okay to have the else statement like we have here now, as long as we've validated our input through this condition here. So we provided this conditional statement. All right, so maybe the last thing that we'll do with this program is actually do some input validation for our soil moisture. So much like what we did here for the seed color, we can do similar things for the soil moisture. So we'll come down here and write some code below this. So after we get the soil moisture, we can test to see if soil moisture is not equal to wet and soil moisture is not equal to dry. Then what do we know? We know that we have invalid input there. So we'll say cout, and then say invalid, let's see, invalid soil moisture was inputted. Maybe input is a better word to use. And then we'll say program will terminate. All right. So we can do that and then do a return 0, and that actually ends the execution of the program. All right, so it exits the main function, just returns it to operating system control. All right, so we've got that, and that looks correct, hopefully. So the soil moisture is not equal to wet and not equal to dry. That means that we do not have a soil moisture that we expect to make use of. And since we have that bit of code, we could actually go in here and have this if statement here, but have this as an else. So we could change this bit of code and have this as an else, much like what we did before. And we could copy this bit of code here, copy that, and then paste it down here for the blue one as well. Do input validation as well here. And then what could we do? We could take this out and change it to an else. Because we know if we make it past this point here, after this if statement here, we make it past, so this ends up not being true, then we must have the soil moisture being wet or dry. Okay, so that's the reason why we can do that else there. Because if it's not wet, it has to be dry if we've made it past this condition here. Now, one thing that may be bothering you about this code is that we have replication of code segments in several places here, right? So we have this replication of code here and replication of code here. And hopefully that's a little bit unsettling to you as you start programming more and more. Anytime you see replication of code, that should be upsetting. But later on we'll look at maybe being able to get rid of this replication of code and write a function. And if we're interested in doing that same operation again, we'll just simply call a function to do that task as opposed to rewriting the same code over. All right, so I think that pretty much wraps up our discussion of Program 4. I guess the last thing we can do is save our program and maybe build it and run it a couple of times. So let's build this and run it. So we'll go ahead and type in red, and the temperature we'll say is 75, and we'll put the soil moisture as, I don't know, let's make up something that doesn't make any sense. We'll just say dirt. The soil moisture is dirt, and hit enter. And it says invalid soil moisture was inputted. Program will terminate. The only other thing I guess we may do is we could just say soil moisture with a space in there. We don't have to use the variable name inside that string literal. So let me change that and put a space in there. And then we can save and rebuild that. So maybe we'll check out the blue and see if it works. So blue, and then we'll put a temperature of 65, and the soil moisture is, we'll say moist, which is not a valid selection. So invalid soil moisture was inputted, program will terminate. So that's exactly what we expect. So anytime that you're constructing a program and you may have multiple alternatives or multiple paths that you can select through the program, it's good to try to test and exercise all those paths and make sure that the program works. And we certainly haven't exercised all the paths for this particular program, so I encourage you to continue playing around with this program and maybe see how you could improve it. I'm not saying it's perfect. Alright, so I'm calling this particular program Program 4S since it's going to be a supplemental program to Program 4. So we have already created the Program 4S project folder and created the Program 4S source file, and I've also copied in our problem statement. And I think our problem statement, the way I've expressed it here, is sufficient enough for us to forego the pseudocode. So basically we just need to get the inputted score, and then based off of what range that score falls in, we'll output the appropriate message. So let's go ahead and start coding. So we'll do our includes, pound include, IO stream so that we can do some input and output, and then using namespace standard, and then we can start writing our main function. So int main open paren close paren, open brace, close brace should be inserted automatically for you. Okay, so the first thing that we need to do is get input from the user. And the input that we're going to be getting from the user is an integer value, so that's going to be the score. So we can go ahead and declare and initialize a variable named score of type int. So int score, assignment operator 0, semicolon. And then once we have that variable declared, we can go ahead and prompt the user. So we'll go ahead and do cout and say enter an integer score between 0 and 100. Okay, and we'll put a period /n for new line character and semicolon. So once we have that prompt there, then we can read whatever they input from the keyboard by using cn. So cn, then use the extraction operator, and we'll say, oops, we should put the variable name here, so score. So that's the basic 3 steps we have for getting input from the user. We have to have a variable declared, then we can prompt the user with some sort of message, and then get whatever they inputted and store it into the appropriate variable. So once we have the score, then we can decide what range it falls on and output the appropriate message. So if the score is greater than or equal to 90 and the score is less than or equal to 100, then we would just simply output awesome. So we'll write awesome here and put the exclamation point. All right, maybe new line character too. All right, so if the score is 90 to 100, we'll output awesome. If the score is greater than or equal to 80 and score is less than or equal to 89, then what do we output? In that case, we output well done. Now, one thing that you'll notice here is whenever I'm writing these Boolean expressions inside of the parentheses here, I'm having to express score in relationship to both the lower bound and the upper bound since I'm writing out both. So it's not good enough just to put score in between 90 and 100. So many of you may be tempted to write this like so. So maybe we have 90 here and then do less than or equal to score and then that operation there. So that may be the way that you think about it. You're saying, oh, well, you know, score here is greater than or equal to 90 and score is less than or equal to 100. Unfortunately, that particular type of syntax does not work. We have to do it like this. So make sure you're writing it like so. And also that you are, in fact, using the AND operation as opposed to the OR operation. Again, if you tried to use the OR operation, we could write in a score like 1,000, and it would qualify on this condition here. And while that would be, this part would be false, so saying we had an OR here, and that part would be false if it was 1,000, but yet you would still output awesome, and that's not what we'd want to have because it has to be on the range of 90 to 100. All right, so we have that, and let's do AND here. And let's see here. All right, so let's come down and do the next one. So if score is greater than or equal to 70 and score is less than or equal to 79, then what are we going to do? We're going to output average. Okay. And if the score is greater than or equal to 60 and score is less than or equal to 69, we will output bummer. And then finally, if the score is greater than or equal to 0 and score is less than or equal to 59, not 590, but 59, then we would, oops, let's see, I got a mistake here. See out. And see out. We'll do sad times. And that's our basic program here. Again, you can have your return 0 statement here at the end. So return 0. That's not really required. If you don't put it in there, you'll probably get a warning, but it assumes that you're going to return 0 if you don't have that return statement in there. So that's our basic program. Let's go ahead and save this, and then we will build it. Now, you'll see here that we have these red squiggly lines under cout. For some reason or another, the new version of Eclipse CDT, the Indigo version, it seems like the code analyzer is very slow on indexing everything so that these errors are actually removed. Eventually, these things will go away, and I need to do a little bit of research and post why that's occurring. If it's just me and the way I have things set up, or if it's something wrong. I think it's something wrong with the code analyzer. This is a new feature within Eclipse CDT Indigo. So everything built okay down here if we look at our console. So whenever we built the program, it was fine. So let's go ahead and run this and ignore that for now. So it says enter a score between 0 and 100. So let's put in the score of 87. And it outputs well done. Let's do another one. Let's run the program again, and this time we'll enter in 55. And it outputs sad time. So it looks like it's working correctly. Now, one thing that I do want to point out about this program is that we construct each one of these conditions with if statements. So if. So anytime that we have an if statement here, it's going to go in and check each one of those. But we know that if we have a score, and that score is between 0 and 100, it can only fit into one of these conditions. It can only meet one of these conditions. So we're actually doing more checks than we should be doing here. So, for instance, if my score was, say, 100, it will still go in and check each one of these. And we can actually verify that that check is going on by interactively going through this program using the debugger. Before I launch the debugger, I want to make a few code changes. So on our lines where we have these cout statements, you'll notice that they end with this new line character, that /n. I want to get rid of that new line character and then come on the right side of our string literal and do the insertion operator and then endl. And so this endl is what we call an IO manipulator. And it works almost the same as the new line character. So it does, in fact, insert a new line. But the other thing that it does that the new line character, the /n, doesn't do is it flushes the output buffer. And what that means is any characters that we had from, say, the string here that were sitting there in memory waiting to be pushed out to the console will be forced out by this endl operation. So it's basically flushing all those characters, that string there, out to the console. And with the new line character, we don't get that. Now, when we run the program outside of the debugger, we really don't notice a difference. But as we run it, this code through the debugger, or use the debugger to step through this code, then we'll see that if we had the new line character in there, it wouldn't actually push all that text out to the screen as soon as we had executed that line of code. So on all these lines here, we'll go in and change this to endl, and you can do the same. Actually, I may do some copying and pasting here, make it a little bit quicker. Let's see. Go back and remove these new lines. Alright, so we replaced our /n with endls. So let's go ahead and save this program and then build it. And this time, after we build it, instead of clicking on this button here to run it, we're going to click on the button to debug it. So we'll still be running it, but we'll be able to interactively go through this program. So go ahead and left click on that. And you'll probably get a little dialog box here that says confirm perspective switch. So you can go ahead and click on remember my decision on this. It's asking, do you want to open this perspective now? And the answer is yes. So anytime that we want to go in and do debugging, we want to switch perspectives. So go ahead and click on yes, and you'll see that the view here, the perspective, has changed. It looks a good bit different than what we were looking at previously. But we still have our code over here in this little window. We have a little window here for debug, and we also have a window here where our local variables will show up. Maybe I shouldn't use the term local variables, we haven't discussed that, but our variables will show up over here. We'll get to local variables soon enough. Alright, so what can we do? So our program hasn't actually executed yet. We're at the very beginning of the main function here, but we can step through or interactively go through this program line by line. So going back up here to the debug area, there's a button here that says step over. So hopefully you can see that button that says step over. Now if this little window is not showing up for whatever reason, you can go here to window here on the menu bar and then go to open perspective, show view, and then select a debug here. So once you select that, you should be able to see this window. All right. So yeah, back to stepping over. So we're going to be using this button here to go through line by line and execute our program. So go ahead and click on that button, and you'll see now that we have a little green shading here on this first line in our main function. So we're about to execute this line of code here. So go ahead and left click again on the step over button. You can also use F6, so if you prefer to use F6, that's fine. So you'll also notice that after we executed this line of code here, we have score, the type of what score is, and the value showing up here in our variables view. So that's pretty cool to be able to see what our values, our variables are going to be, and also the current value of those variables. All right, so the next thing we're going to do is execute this enter an integer score between 0 and 100. Now, if we did not have this indel here and you kept the /n, then whenever we step over this line of code, so I'm going to go ahead and step over it, you wouldn't see that actually coming out on the console straight away. It may take a few lines of instruction before it actually flushes that buffer or pushes the string or the text out to the console. All right, so now we're going to step over again. And this time we've got to input something. So we'll input the score 95 and hit enter. And now you can see up here in our variables view that the score's value has changed to 95. It was 0 and now it's 95. So now we'll do this test here. We'll test to see if our score is greater than or equal to 90 and our score is less than 100, which it is. Let me scroll down a bit so you guys can see that. And I'm going to click on step over. And so now, since we tested true for this, and we're now in the body of that particular if statement, we're going to execute the cout statement. So we should see awesome show up, and we do. But now what you'll notice is, since we have if statements in here, each one of these if statements will be tested. And that's not necessarily a good thing for this program, because we know that the way we set up these ranges, our score can only fall into or be test true for one of these conditions. So we're testing these unnecessarily the way we have our logic here. So it tests that one, then it tests the one for 60 to 69, and then finally 0 to 59. So all those are unnecessary tests. And then finally it gets to the return 0, and then we're pretty much done with our program here. Okay, so let's switch perspectives back to our normal editor. So up here on the right hand side we have the debug perspective. But if we go over a little bit, you should see like two little arrows. It almost looks like our extraction operator, but it's not. Just left click on that and then left click on the C/C++, and that will switch us back to the original perspective that we had for editing C and C++ programs. So we'll do that, and we can close this little error message here, so ignore that for now. And we're back here to our code. So what we're going to do now is actually change our code a bit so that we're not testing each one of these conditions. We want to write this so that as soon as we test one of these conditions and that condition evaluates to true, we don't want to test any others. And the way that we can do that is using the multiple alternative else if. So after this first if, we can replace the rest of these with else if. And you can even replace this last one with an else if, but we can actually do one better than replacing it with an else if. If we've exhausted all other possibilities, we could actually write this last alternative as an else. So we can get rid of the test. We can say, okay, we've tested every other possible scenario. We know it has to be sad times if they didn't make the right score or whatever. So let's go ahead and save this and compile it, and we'll see the difference here. So let's save it and build it. So it's compiling and linking it. And now we'll launch our debugger again. So I'm going to go ahead and step over, just like we did before. So our little step over button here, our F6. Step over again. So we see now that we have our score here, and its value is currently 0. Now we get our output. And now we need to step over. Now don't try to input any values here until you've actually stepped over the CN line. If you don't step over that CN line, it's not going to be trying to get input from the user. So we got to do that. Step over. So now we can input a value here, and I'm going to input the value, I don't know, let's input 85 this time instead of 95 and see what happens. So we'll hit enter and see what happens. So it's about to test this condition here. I'm going to scroll down just a little bit. So if the score is greater than or equal to 90 and score is less than or equal to 100, obviously 85 does not fall into that condition. So let's go ahead and step. And so it skipped over. It didn't go inside of this if statement here. So we had that if condition, but it didn't make it inside of the body because that returned a false value when we evaluated the expression here. Now it looks like we're going to qualify here, right? Because the score is between 80 and 89. So we'll step over, and you'll see, in fact, that it does go to the C out line. So we'll get well done here. And whenever I clicked on step over again, it took me all the way down to the last statement. So it skipped over all these other alternatives because the way we constructed that using the else if. So there's a big difference between using else if and if statements. If we have if there, it will test those. If we have else if, as soon as it meets a condition and executes the associated expression statements for that particular condition, it doesn't bother doing anything else. All right, so let's go ahead and stop this program. We can click on the terminate button here, and we'll switch back to our other perspective for the editor. And the last thing that we may want to do, I guess we could end up in a situation where someone inputted a number like -50, and -50 would end up printing out sad times, but actually that's not even a valid score. Our score is supposed to be between 0 and 100. So up here we could actually put in a test to check and see if the score is less than 0 or the score is greater than 100. Because we know if the score is less than 0 or if the score is greater than 100, we have an invalid score. So go ahead and put in an open brace on the next line. And here I'll just do cout and say an invalid score was entered. I'll say inputted maybe. And we'll say program will terminate. Okay. And maybe we'll use our endl. So let's see. Insertion operator endl, semicolon. All right. So once we do that, we can do our return 0. If you want to, we'll save this and test that out real quick just to make sure that that does work. So save that, build it, and then launch our debugger again. So let's go in here and run it one more time. So use our step over. We'll declare and initialize our score variable. And then we get this outputted to the console. And this time we'll type in, I don't know, -50 and see what happens. So it gets the value -50 assigned a score. Step over again. And you'll notice that this time we're testing the condition to see if the score is less than 0 or the score is greater than 100. So if either one of those conditions are met, then we want to say that we have an invalid score inputted. So that's going to be true. We'll get that outputted, and then we'll just simply terminate the program at that time. All right, so you can go ahead and click on terminate, and then flip back to our original perspective. So we've looked at several things here. We looked at using the else if as opposed to just using the if. We saw the difference between using if and else if. We looked at using the endl and what happens, why we would want to use endl as opposed to using the new line character. Usually if you're going to be using the debugger and you want to see your output immediately, I would recommend using the endl. So yeah, we've seen quite a few things here. So that's it.